All right, so I'm going to be honest with you. I could be wrong, but I know it's one of the first two. One of the first two questions deals with this on the multiple choice part of the test. So we're going to go ahead and just look at it real quick. Like, it's not this question, I'm telling you, but it's like this kind of question. So suppose an element consists of three naturally occurring isotopes, and we looked at this at the very end yesterday, but I want to go back and just show you what I was talking about. The reported average of the mass, okay, reported average mass. So this is what will be found on the periodic table. That's the number actually up there. And if you actually have the periodic table, is there a mass that is 75.42? No. So is there it's between two, right? It's between what? Arsenic and selenium? Yeah, okay, so it would be in between those two if it were real. So you can't tell me who this is because it's not a real thing. The following information is known. Isotope 1 has a mass of 80.45 and makes up 2.4% of the element's atoms. Okay? All right, so if I handed you a bag of 100 atoms, okay, and I told you that there are three different mass atoms in that bag, so atom 1, atom 2, atom 3. One of the atoms weighs 80.45 grams. The other one weighs 72.2, and then it says we're trying to find the mass of the missing one. But of that 100, how many of them weigh 80.45? Almost 2.5 of them, right? So obviously you can't have 2.5% of atoms, but it's based on an average. Okay, so isotope 2 has a mass of 72.22 and makes up 30% of the element's atoms. What would you estimate as the mass of isotope number 3? All right, so here's what we have going on, and I'm actually going to go back to this from yesterday. Actually, I can't because I lost that thing. So let's just look at it from this perspective. So ISO 1 times percent plus ISO 2 times percent plus ISO 3 times percent equals average mass. Would you agree with that? Okay. Now, what is the mass of isotope number 1? 80.45, and what is its percentage? Okay, now can you plug 2.4 in? Now, and I'm begging you, and I know that this is going to happen. I see people do it every year. I see people write 0.24. Very good. 0.024. And I know that that's easy to do, but you have to be sure that you make sure you move it 2 places, not 1. All right? Plus, what's the mass of isotope 2? And what's its percent? So 303. Oh, I'm sorry. I thought you said 30.3. My bad. Okay? And then plus, and then the question is then, what would you estimate as the mass of isotope number 3? So would you agree that the question is that we're searching for that number right there? All right, well, there's a problem. They did not give us something else that we need about this thing. But is it able to be found? How would you find the percent? Add it up and subtract from 100. All right, so what percentage did you come up with? Okay, 67.6, so 0.676 is equal to that. And then the mass that they gave you was 70-something. 0.42. Does that make sense? So what would you do here? Find x. Does that make sense? And I think we've actually already done this, haven't we? Okay, and it came out to be 74. Yes, ma'am. Okay, I like simple questions. 2 places. Okay, all right. That's the wrong button. So would you agree that this is 2.4%, right? So 1, what has to go in there? The 0. So that's 0.024. The other one was 30%, right? So I start here, 1, 2. So that's equal to 0.30. Does that help? Okay. And that's why I actually stopped and said, make sure you know what your decimal is of your percent, because it's easy to mess it up. Okay, yes ma'am. Okay, that's a good question. Let's go back and look. All right, would you agree that they gave us that percent? Okay, which is really 2.4. They gave us that percent, which is 30, right? But they did not give us that percent. What should all percentages always add up to be? 100%. So you take 2.4 plus 30, which is 32.4, and subtract it from 100, which is 67.6%. Does that make sense? Okay. Any other questions on that one? Good deal. Go ahead. Like if pretend you're back in 8th grade in math, you'd multiply those two, add them together, subtract from the other side. It's equal to that. This whole left side is equal to that number. That's the answer. That's X. Does that make sense? I just did it really, really quick. We solved for X, and X is 74. Does that help? Okay. All right, next. I do want to throw this at you real quick, because they do it without any math. They say provide a reasonable estimate. Choice 2 provides a reasonable estimate. Since the average is approximately 75. Do you agree it was 75 point something? The third isotope must be slightly higher than that to balance the 72 value, but since the 72 mass of isotope is only 30% of the atom's, isotope 3 with approximately 75% would not have to be very much greater. Does that make sense logically? Let's go back and look at the question. All right, so this was the average, right? The two masses they give us are 80.45 and 72.22. Our average is 75. Okay, well this is only 2%. This is 30%, and that leaves us how much left? Almost 70%, right? So what number up there is closest to 75? 74, because it's the highest percentage. Does that make sense logically? Okay. All right, good deal. All right, next one. Consider that a diamond and jewelry atom is made up of only one carbon atom. Made up of only carbon atoms. If the diamond has a mass of 0.2 grams, about 1 carat, how many atoms of carbon would be present? Okay, so we have 0.2 grams, 12.0 gram, and we're talking about carbon, right? In 1 mole, and then 1 mole of carbon is 6.02 times 10 to the 23rd. So what you think it's going to be? What is it definitely not going to be? Definitely not 1 or 2. So if you divide 0.2 divided by 12, sir? Thank you. Okay, it is 3. When you divide a decimal by a whole number, is your answer a big number or a small number? So when you do 0.2 divided by 12, it's going to be small. Small number divided by a big number still keeps it small. So when you multiply a small number by a really huge number, is it going to pull the scientific notation value down? Yes. Okay. And it did to 22. Excuse you. 23rd. Yes. 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 That number, yes. Matter of fact, is it on the formula sheet? I think it's on there. It's on the front at the top if it's on there. But to be honest with you, I can't tell you very many times on the AP test where you've actually had to use that number. Yeah. Okay. All right. Yes. But we're going to work as we celebrate. We still get to eat. We still get to celebrate, but we work. Okay. The compound chromium 3 oxide, we've already done this, right? Yes, we've done this one because we did an atom to molecule ratio. Okay. Question 4. Hypochlorous acid is related to which anion? It's number 4, ClO negative. Next question. Morphine, derived from the opium plants, has the potential for use and abuse. Its formula is C17H19NO3. What percent by mass is the carbon in this compound? Now, I need to make an emphatic point here. When you say percent, what is a percent? Part over whole. What are we trying to solve for? We're trying to find which part? Carbon. So we're trying to find the percent of the mass of carbon versus the mass of morphine, right? Now, this would be really difficult to do without a calculator. Would you agree? Yes. Okay. So, what did anybody get the total mass of that morphine thing? 285? Really? I was expecting more than that. All right, how much of that is carbon? Now, is it more than 50%? Then do you have your answer? You don't even have to do the division. Now, honestly, I could have looked at that and known it was more than 50%. How? Look how many carbons you have. Nitrogen's 14, but how many of them are there? 1. Oxygen is 16, but how many of them are there? Carbon is 12, but there are 17 of them. Does that make sense? So it's got to be a very high percentage. Does that help? Okay, logic must reign true in this as well. And let's look how they did it. First, determine the molar mass of the compound, then divide the total mass. So they actually did the whole thing. No, this is just formula mass. Molecules. Remember, part over whole is only percent. Okay. No, that's talking about grams. That's talking about Trevor. Thank you, guys. Please stop. That's talking about grams, moles, or atoms. Percent is talking about a percent. It's different. Okay. All right. The dye indigo is a compound with tremendous economic importance. Blue jeans would be blue without it. Indigo's percent composition is 73.2% carbon, 3.84% hydrogen, and that about nitrogen and that about oxygen. What is the empirical formula of this stuff? Now, I'm not going to go through the math of this, but what's the first thing you got to do to all those percentages? Grams. And then once you have grams, what do? Change them to moles, and then do what? The smallest number of moles, and then what's that value got to be? Within 1/10 of a whole number. What'd y'all get? Y'all got 3? Sounds great. Again, I'm not going to work all that math out. You guys should know how to do the math on that. That's pretty simple. Okay? The next one. We've already done that one. We talked about that one yesterday. Yep. The reason it's the last one, C2H6O2, is because it cannot be reduced any further. So it's automatically empirical, and it also can be molecular. Okay. Agriculturally, the following equation is important because it is used to make millions of tons of urea. When the equation is balanced, how many hydrogen atoms will be present on both sides of the equation? Also, how many moles of NH3 would be needed to react completely with 0.5 moles of CO2? Well, let's balance it first. All right, I've got 1 N, 2 N's, 1 C, 1 C, 2 O's, 2 O's, 3. So I already know that I'm probably going to need a 2 here and a 3 there. Does that get me what I need? You're right, I don't need the 3. Thank you. And how do I know I not need the 3? Because 2 times 2 is what? 4 plus 2 is All right, what's 2 times 3? 6. Fantastic. All right. So the first question is, how many hydrogen atoms will be represented on both sides? So how many? All right, well, that automatically knocks out 1 and 2. Would you agree? All right, the next question is, it says how many moles of NH3 would needed to react completely with half a mole of CO2. What are they asking you to do? They're asking you to do a mole-to-mole ratio, right? So, and I'm just going to show it just to make sure that we're on the same page, but if you've got 0.5 moles of CO2, can you go from mole of CO2 to mole of NH3? Yes or no? What's your mole to mole? What's 0.5 times 2? Answer is 3. Does that make sense? Do you see what they're asking you to do there? Or you could look at it logically and say, well, if I need 2 moles for every 1 carbon dioxide, how many carbon dioxides do I have? Half of 1. Well, if I have half of 1, then I only need half of my ammonia. So I need 1. Does that make sense? Yes, no, maybe? Good deal. Okay. Next question. Calcium carbonate can be a common antacid ingredient. The unbalanced equation shown here represents calcium carbonate reacting with hydrochloric acid found in your stomach. And you've got that equation. How many grams of CaCO3 are required to neutralize 25.8 grams of hydrochloric acid? What are they asking you to do? Stoic, gram to gram. Okay, I'm not going to spend time. My first question is, anytime you do a stoichiometry problem, what's the first thing you got to have? You can't do any stoichiometry without it. A balanced equation. Is that equation balanced? It's not balanced? All right, we've got 1 Ca, 1 Ca, 1 C, 1 C, 3 O's, 3 O's, 1 H, 2 H's, 2 Cl's, 2 Cl's. So what could you do there? Put a 2 in front of that. Now, all in all, did that 2 matter? Yes, it mattered, because you started with hydrochloric acid and you're trying to get to calcium carbonate. After you did the stoichiometry, what did you guys come up with? Anybody disagree with that? Do you want to see it? You did gram to gram. Do y'all want me to show it to you? All right. It's 25.8, right? All right, so 25.8 grams of HCl. I've got grams of HCl to 1 mole of HCl and mole of HCl to mole of CaCO3 and then mole of CaCO3 to grams of CaCO3. I know that this is a 1. I know that is a 1. I know that this is a 1 to 2. And this is 36.46 because I know that math, but I have no idea what that number is. So whatever that top mass is, anybody see that real quick? Come on, throw that at me. That's right, it is. It's an even 100. Forgot that. So 100.09, and then you just run the math on that. Does that make sense? Okay. 35. If you did not balance that problem, would you have gotten this one wrong? Yes, you sure would have. Okay. All right. Number 2, the next one. If 2 compounds are about to react, which statement about the reaction states an accurate observation? If the temperature conditions can be kept optimal, both compounds will fully react with no excess. The reactant present with the fewest grams will be the limiting reactant. The reactant present with the fewest moles will be the limiting reactant. None of these statements are accurate. Can you ever say just because it has less grams it's going to be the least? No, that is definitely not true. Temperatures, but there's always going to be some sort of excess unless you did it perfectly. And even then, on the atomic level, it's never going to be that way. So the answer is choice 4. None of the statements are true. A limiting reactant can be determined only when both of the moles of the 2 compounds and the mole ratio by which the compounds react are known. So that's kind of a tricky one. So you can't just... Exactly. So you have to compare their mole to mole. You can't just say, okay, well, that's the least. Because remember, what is our definition of limiting reactant? The moles divided by what? coefficient if you don't account the mole-to-mole ratio, because where does the mole-to-mole ratio come from? Does that make sense? If you don't account for that, it's wrong. Okay? Which would provide more grams of NaCl sample? The one with the mass of 2,350 milligrams, or sample 2, a solid with a volume of 2 cubic centimeters. The density of solid salt is that. All right, so here's what I'm going to do, because I actually want to go through this one tomorrow. So I'm going to pause because we're running out of time. So I'm going to pause this and remind me to start with this question tomorrow.